Hi, in this video we are going to look at three more features related to intelligent uplink selection. First one is policy-based routing or PBR, the second one is ISP routes, and the third one is health check. So let's start with policy-based routing first. Policy-based routing or PBR is a mechanism that allows data to be forwarded based on configured policies. For example, the policy requirement here is that employee group A uses ISP1 for its traffic and employee group B uses ISP2 for forwarding traffic to the internet. This can be implemented by using, this is a policy which we want to implement, and this policy can be implemented by configuring PBR or policy-based routing on this firewall. Policy-based routing can very easily make sure that the traffic from certain source computers or certain sources, source networks or source zones is forwarded through certain uplinks of our choice. These are the components of policy-based routing. What happens in policy-based routing is that we first match certain conditions, and based if those conditions are matched, we take certain actions. What are those matching conditions? These are different matching conditions for the traffic. If the traffic matches any of these conditions based on our configuration, this means that this traffic we should take appropriate action on this traffic, and these are the actions which we can possibly take once the traffic has matched one of these conditions, one or more of these conditions. These conditions can be security source zone. We can do policy routing based on security source zone or the inbound interface or the IP address or MAC addresses, user type, service type, application type, or DSCP priority. These are the different matching conditions which can be checked against by the firewall, and then the appropriate action can be taken. What are the actions? We can forward traffic to a specified next hop device, we can forward traffic to a specified outbound interface, we can enable intelligent uplink selection, etc. So these are the different actions which can be taken when we are configuring policy-based routing. If you look at the configuration process, or the rule matching process rather, you can see that we configure different rules within the policy-based routing framework, and the traffic is matched against those different rules with the matching conditions. If any matching condition is matched, or if any matching condition is met in a sequential order, the associated action will be taken. If the traffic does not match the first condition, it will be checked against the second condition in the second rule, or the conditions in the second rule, and then the appropriate action will be taken. If the traffic does not match the conditions in this rule as well, rule B, then it can be checked in the conditions in rule C, and so on, until if one of the conditions is met. If no condition is met, then the traffic is going to be forwarded based on the routing table, which means that policy-based routing has not been configured to handle this traffic, and this traffic needs to be handled by the ordinary routing table. So this is how policy-based routing works. We are going to look at a configuration example of policy-based routing in one of the subsequent videos. But for now, let's take a look at the concept of ISP routes. ISP routes is an interesting concept whereby we see that we want to access two resources. Either we can access the resources on server 1, or we want to access the resources on server 2. Now server 1 is situated within the ISP1 network, and server 2 is situated within the ISP2 network. In this situation, we see that the shortest path or the optimal path for reaching server 1 is through this link, and the optimal path for reaching server 2 is through this link. However, if we try to reach server 2 through this particular link or through ISP1, if we can do that, then this would be a case of suboptimal forwarding or suboptimal routing, and we do not want to do that. In order to avoid this scenario, avoid this situation, that resources that are present, for example, within the ISP2 network, we are using ISP1 network or ISP1 link to reach those resources, which would be a case of suboptimal forwarding. we can use the feature of ISP routes to avoid this situation or avoid this scenario. How we do that is that we create an ISP address file. This address file contains the different networks or the different IP addresses that belong to a specific service provider to which we are connected. What we do is that we import this ISP address file into our firewall, and then we associate this firewall we associate this file to an ISP's name, and as soon as we assign an interface to this particular ISP, all the routes or all the networks that are present in this address file, for all those addresses, static routes are created by the firewall, and the next stop for all those static routes is going to be the gateway IP address of that particular service provider, which means that all the addresses that exist within an ISP infrastructure or within the ISP network are going to be reachable through the link that connects us to that particular ISP. In this way, we are going to make sure that we always use that particular ISP's connection to reach all the routes within that belong to that specific ISP. And these routes which have been dynamically or which have been created on the go by the firewall, these are called user network routes or UNR, and their priority is 70 as compared to static routes priority which is 60. So this has got slightly higher priority, higher priority number. However, their preference is lower than the static route. If you look at the configuration, you can see that the intelligent uplink selection, what we're going to do is that we select the carrier address library. In the carrier address library, we import either one of the files might already be present there for a specific ISP. Otherwise, we can import the file with a specific name. This can be the name of the ISP, and then we browse the file and we upload the file to the firewall. Once the file has been uploaded to the firewall, then we go to the interface and we associate this interface. You assign the interface the IP address, any particular interface, and then we can associate the particular file that we have created or imported. We can select the carrier, which means that this is the file or this is the carrier which we want to associate with this interface. So as soon as we select this, all the networks that are present in this carrier's file, they are going to be assigned, or their static route is going to be created for all those networks with the gateway address of this particular ISP. So this is how ISP routes are going to be selected for the networks which belong to that particular ISP. And this is going to help us avoid the suboptimal forwarding within our infrastructure. The last feature that we are going to discuss in this video is the health check feature. The health check feature is a fairly straightforward and a very logical feature in the firewall, whereby the firewall continuously checks the health of the links through which it is connected to the ISP, so that if any of the links is unreachable or any of the destinations or services is unavailable, the firewall can select alternate paths for sending traffic to that destination or for that service. So for example, if the firewall detects, based on the probe traffic that it is sending to different resources, if it detects that one of the resources is unavailable or unreachable through this link, it will stop sending traffic through this link and will start forwarding that traffic through ISP2 or ISP3 links. So if you look at the text here, it says after health check is enabled, the firewall can detect the fault on ISP1 link as shown here. When traffic triggers intelligent uplink selection, the firewall does not select ISP1 but ISP2 or ISP link 3 to forward the traffic. So these two links are going to be used, and the link through ISP1 will not be used because the firewall has detected due to health check that this link is not healthy and this link is not available. So this is another demonstration of how ISP or how health check is going to make sure that we are able to reach the destinations, or we are able to reach the resources which are not available through a specific link. For example, if you want to reach server 2 and this server is reachable through this link, however, there is a fault within this infrastructure, within this ISP network, and we cannot reach this resource, then we can, because of health check feature, because of the probe traffic that is being sent by the firewall to this server, you would be able to detect the loss in reachability, and then we can forward the traffic through the alternate link through ISP1. That is, if ISP1 and ISP2 are reachable through each other's networks, then our traffic will be reaching this server 2 through ISP1. Although this is a suboptimal path, but this is the only path that is available to us after this path became unavailable. So in this way, even though we are using suboptimal path, however, we are able to use the service and we are able to reach our destination server. And this was made possible because of the health check feature which is being provided by Huawei Firewall. How does this health check mechanism work? The firewall can send probe packets of relevant protocols to different types of destination devices and determine link availability by analyzing the response packets. So depending upon the service that we want to check or the health check that we want to do for a particular service, the firewall sends different types of probe packets to those destinations, and depending upon the response from those destinations, the firewall can detect whether the service is available or not, and if the service is unavailable, the firewall can use alternate paths for reaching the destination. So this is how health check helps us make sure that the service availability is maximized and we can reach the destination through any of the available links. So this was the global route selection, policy-based routing, ISP links, and health check. In the next video, we are going to look at the different configuration scenarios or different deployment scenarios of intelligent uplink selection. So see you in the next video.